I'm going to talk about the chemistry of cleaning, continue to build the foundation of what you've been hearing so far with a little bit more focus on actual chemistry and actual chemicals. And I will refer to chemical names occasionally that might be kind of weird. Also VOCs. Does everybody know what a VOC is? Volatile organic chemical, commonly known in our place as very odd chemists, so whichever you'd like to refer to. But anyway, chemicals are obviously a very important component of our society. Just about everything that you know, everything that you see has some chemical constituency in it, so we can't really get away from it. I think in terms of cleaning, the importance of chemicals in cleaning, they do have their importance, they do have their place, but I think we also have to realize that we can have potential risk associated with chemicals in cleaning. Cleaning serves very good purpose in terms of hygienic reasons. We've heard many of those this morning so far. Preserving aesthetics in our buildings and in our materials, and also preserving the longevity of materials. I think it's also important to realize some of the statistics that we're learning relative to cleaning, that currently we have somewhere between 3 and 4 million people involved in the cleaning industry that are exposed to cleaners on an everyday basis. That about 31% of all consumers will say that they have experienced using cleaning chemicals within that very day, and that over 30% of consumers now use air fresheners in their homes to try to mask odors and to provide a pleasant environment. So with that type of information, it becomes very obvious that we are using these chemicals and cleaners very frequently, and that we do run the risk of exposure and adverse effects from that type of activity, while in the same time we have to realize the benefits of cleaning, and that we will have to do it. It is important to, as Dr. Berry says, remove the unwanted matter from our environment, and cleaning is the process. I think another important thing that I want to spell out in the beginning is that we really have very little scientific documentation on how effective our cleaning processes are. We know a lot about what they are, what the chemicals are, how we use them, but really very little in terms of how effective. Most of the studies that have been done there have been a fair number of studies on the effectiveness of carpet cleaning and removal of dust and bioallergens. There have been some whole building studies, like the Frank Porter Graham daycare building that you heard about earlier from Gene Cole. But overall, few studies, and that's one area that we really need to fill in, because we need to understand how effective they are in order to continue the evaluation of the risk elements and the prolific use of chemicals that we have going on today. So in my presentation, I'm kind of going to go over a general review of cleaning processes, chemicals, potential hazards, and kind of where we might go from here. The removal of soils, and some of you probably know this content even better than I, but there are different types of soils that we're trying to remove from our environments. Organic soil, which is probably one of the most common, especially in the indoor environment where we're removing food, living matter. And in general, we use alkaline or basic types of cleaners to do that. We have inorganic soils, which are minerals, rust, things like that. And in order to remove those, we're typically looking at acids, which are on the other extreme of the alkaline cleaners, the acids with the low pHs. We have petroleum soils, and in order to remove petroleum soils like oils and greases and things like that, the only way to do that is to use a similar type of solvent, a petroleum type of solvent, to remove them. And then we have combinations of all of those soils where we may be using combinations of different types of cleaners. There's some basic processes by which cleaners work. Some of these are very simple, very common sense. Solvency, which is merely the process of adding a solvent to a surface or to a material, having that solvent reside on that surface of material so that it actually dissolves the soil that we're trying to remove and so that it can easily be removed. Detergency, which is the act of actually applying a soap or a detergent, which works its way into the soil, essentially causes the soil to almost rise to the top or to end up in a manner so that it can be easily removed through either a wiping or mechanical type process. There's chemical reaction, where we actually apply a chemical to cause a chemical reaction so that we can reduce the soil to another form so that it can be removed. And a very common example of that is the use of acids, where you often add an acid to dissolve mineral salts into form so that they can be removed. And then there's mechanical processes. Mechanical processes can be as simple as using a sweeping action with a cloth to actually sandblasting up something that is hard residue on a particular surface. We often see sandblasting of subflooring being done in buildings to clean up residues that have accumulated on them from adhesives and other coatings that have been put down. But those are kind of the basic principles that one follows to actually clean. Now this is where we get into the chemicals. When we talk about how we do that, we find out that we use a lot of chemicals in the process. And if you look in some of the literature, some of the information, you'll see about 28,000 different chemicals that are currently registered to be used in consumer cleaning products. That's a lot of chemicals. And they are all types of chemicals, and these are some of the common ones that are in the majority of cleaners and ones that many of you have probably heard of. Some of the more important ones, surfactant, which is a surface active agent. And a surfactant, I think most cleaners have multiple surfactants in them, but a surfactant is kind of an interesting chemical because it's got a water-loving part to it and a water-hating part to it. And that's what makes it so effective. A surfactant is hydrophobic, meaning it doesn't like water. And that part of the surfactant is able to come out of the solution and actually adhere to soiled surfaces so that it can actually start attaching to those soils. So the surfactants have the water-loving part as well, which helps the solution wet the surface so it glides across the surface or within the material and combines with the other aspects to make an efficient way of removing the soil. Another very common one, class of cleaners called builders. And builders are traditionally substances that are added to the water to soften the water, I guess is one way of saying it. There are a lot of minerals in water which can make the water hard. But builders are added. They actually sequester or capture those minerals and either deposit them out or change them in form and that type of thing. A common builder that's used today is a chemical called ethylene diamine tetraacetic acid, EDTA, which hopefully many of you have also heard of. But that chemical works in a way, it's called a chelating agent or a sequestering agent. It's kind of like a claw. It just kind of captures those minerals and binds them up so that they can't be in solution in the water. Those two chemicals are probably very key to all cleaning agents. And then there are a lot of other chemicals of various types. There are acids, phosphoric acid, hydrochloric acid, occasionally sulfuric acid used to dissolve minerals and that type of thing. You see them in a lot of toilet bowl cleaners or bathroom cleaners where you deal with rust. There are preservatives that are added to cleaners that are chemicals, and preservatives are needed to, as they indicate, preserve the product so that it stays good over time, to address issues from decay or rancid things that can happen with them. EDTA is often used as a preservative as well. Another preservative that used to be commonly used was formaldehyde. Fortunately, formaldehyde is being phased out of a lot of products and not in them anymore. A couple of other very important ones, obviously solvents, because they remove the hard-to-get greases and soils and things like that. Solvents are usually very organic-based, and the common solvents you hear about are your chlorinated ones, such as tetrachloroethylene, perchloroethylene. Again, those chlorinated solvents are being phased out over time, and some of the more common other types of solvents are your glycols and glycol ethers, ethylene-based glycols, butyl cellusolve, butoxyethanol is another name for that. Last but not least, among kind of the important ones, enzymes, and that's probably one of the newer approaches to cleaning, where enzymes are now being added to cleaners. And those enzymes are chemicals that are called protease and amylase and things like that. And really what they do is break down the substance, break down the soil into amino acids. And they work well on things like protein, spilled milk on your shirt, things like that. Break the substance down so that they can be extracted more efficiently. All of those type of chemicals actually serve functional purposes. And then we have some others that are added to the mix that serve additional purposes, and that's something like a colorant. Colorant is a chemical, but it's usually put into a cleaning chemical to be an indicator of whether it's there or not, or whether it's being active or not. And you've all seen the blue in your toilet bowl maybe, and that's a good indication of a colorant. So it's not really serving a cleaning purpose, but it's a chemical that's added to the mix. And another group that falls into that category are odorants and fragrances. And they generally don't serve much of a cleaning purpose, but again, they're added purely to provide a fragrant odor that people perceive to be desirable. And I think I indicated earlier, some of the statistics show that over 30% of all households today are now using fragrance and deodorizers. So that's just kind of a mix of some of the general types of chemicals that are used, many of them and many, many types. Now, cleaning processes, as we've already discussed, are being used in all environments, from the residential environment crossing over to healthcare, educational, as well as commercial. Cleaning is important to all of these environments to help protect health and also to provide a pleasant, productive environment for all. The good things about cleaning, obviously, they do provide a very positive purpose to protect public health, to reduce potential exposures to contaminants that we have in the environment that may be allergens, dust, respirable particles that we can breathe in, and other toxic chemicals that may be coming from other sources. Cleaning processes also remove chemicals, but the bad part of that is that they can also introduce chemicals. And they can introduce not only unnecessary chemicals, but they can also introduce unnecessary particles that can become airborne and allergen and be allergenic to people that are being exposed. And these things can accumulate both on in the air as well as on the surface of materials in the environment. Now, one of the very important facts behind the significance of cleaning on health is the fact that people spend about 90% of their time indoors, whether that's in their office, their home, transportation, wherever they are. People are in this indoor environment. And that's one of the reasons there's been a lot of focus on indoor air quality, the importance of protecting and preserving that environment to be free of unwanted contaminants like chemicals for those that are being exposed. Overall, there are a lot of chemicals. If we were to test the air in here today, we'd probably find about 300 to 500 different chemicals. Sources of those are many. We bring in chemicals, the materials that we have, the personal care products, all of the materials in this room, from the paint, the wall, the ceilings, the flooring, the light bulbs, everything's kind of contributing to that chemical mix. Some of the more interesting data that we are seeing, and this is coming from some of the studies that are being done in buildings, and I'm going to focus specifically on schools because that's where I've seen most of the data. A lot of concern about indoor air quality in schools. Over 50% of the schools in the United States have indoor air quality problems, and there's a lot of focus on that because they are children who are more sensitive to these types of exposures, and also it's an emotional issue, and it's also something that our government entities can focus on. But on the data on chemicals in schools, there are studies going on where chemicals in the air as well as chemicals in the dust are being reviewed. And the majority of I think 18 out of the top 20 chemicals that are being found in the settled dust in schools are cleaning-related chemicals. And they're chemicals like butoxyethanol, for example, which I mentioned earlier. Some 1,4-dioxane, which is a solvent-type chemical, which is a class 1 carcinogen, naphthalene, paradichlorobenzene. So because of that, there is going to be a continued focus on the presence of these chemicals and how they can be used to be effective, but also removed from the environment as well. The other study that's going on along that line, which is very important, is a study being conducted by CDC, and it's called the NHANES study. Are you all familiar with that? NHANES stands for National, I know, I get confused, but it's a National Health Examination Program. And the CDC takes a certain percentage of the population on a yearly basis, and it's random. They go out and they take these mobile trailers and they actually do these major physical workups on the people. And out of that's the data that generates the statistics on the obesity rate, heart disease, and that type of thing. Well, 2 years ago, CDC decided that, wow, we believe environmental exposure is a big concern for people in general. And so they added the element of looking at settled dust analysis of all of these people in the homes of all of these people they were doing medical exams on. And they're doing about 400 or 500 a month. And so the settled dust data is being reviewed for chemical content as well as microbiological content. And I've only seen the first year of data so far, but again, the data is indicating that a majority of the chemicals being found in the dust are either tobacco smoke related or chemical cleaning related. So data that is being generated that you'll probably hear more about. I'm going to show a little bit of data for those that might want to see some data relative to some of the cleaning effectiveness studies that have been conducted. This is an example of a type of study where the volatile organic chemicals, VOCs, were actually looked at in a school environment following a cleaning process. And the cleaning process was flooring where actual carpet in a classroom was cleaned, as well as hallways where resilient flooring was cleaned. And this is kind of where the building was before the cleaning started. This green is the level of VOCs that were residual in the air 12 hours following the carpet cleaning process, which was a hot water extraction process. This particular one, which is very high in comparison, were the chemical levels that resided following a stripping and finishing of the resilient floor. So as you can see, there is a difference in the cleaning processes in terms of their potential contributions of chemicals into the air. And also, this particular data is presented as what we call TVOC, which is a combination of all the chemicals that were there. This particular bar graph represented about 60 different chemicals that were residing, and this one about 10. So the efficacy in terms of the removal of the dust and the allergens within the carpet were very positive for this particular study, but it did show that we were impacting the environment around us through the process with chemicals. Now, the problem with that type of situation is that when you have indoor air quality issues like that, it leads to what traditionally has been called sick building syndrome, or where people are affected mainly by irritation symptoms in terms of upper respiratory, mucous membrane type symptoms, nose irritation, eye burning, headaches, that type of thing. And these are some of the very common types of symptoms that people experience, especially when that TVOC level starts to get above 1,000. And if you saw in the previous slide, we were up to 18,000. So people that were exposed to this would have expressed negative responses. The other important aspect of all this are the other types of health symptoms besides just what we call irritation. And number one are asthma and allergies. And I'm sure everyone knows that the asthma rate among children continues to climb in the United States, and actually it's true on a global basis. 1 in every 10 child is now diagnosed with asthma, and even more than that with allergies. And another fact that I didn't put on the slide that I think is very important is something that CDC is tracking is autism. Autism is a neurological disease that is affecting children. 1 in every 100 child is now diagnosed with autism. And there is a strong belief that those type of illnesses and situations are closely related to environmental exposures. There may be multiple types of environmental exposures, but there is a concern. And also in terms of long-term type health effects, and this would probably be more relevant to your occupational professionals who may be working with chemicals and situations for long periods of time on a routine basis, that long-term exposure can lead to more significant health concerns from this aspect. Talked about asthma, so I'll skip that particular one. There is a very nice Academy of Science report on asthma, if anyone is interested, that talks about environmental exposures. It talks about the potential of these types of chemical exposures being causal agents in the increase in asthma and allergies among people today. So the science is beginning to develop to really understand those potential causes. There are also a lot of very significant economic impacts of those type of problems in buildings. It's costing a lot to deal with it, and it's also costing a lot in terms of on the business side, relationship side. If you go into a building to do something, or you are associated with a situation where you end up with indoor air quality problems, where people believe that a process or an activity has caused their problem, it can really create a liability situation as well as strain relationships with your customers, negative publicity overall on the actual processes or what's being done, and something that one typically would like to avoid. We know a lot about these particular issues and the cost that it's causing on the healthcare side. We also have a lot of statistics showing us the savings that we can have if we do address these issues and reduce these types of exposures and responses from people overall. Now, getting back to the cleaners, those are some of the issues that we're dealing with. And getting back to the cleaners, you know, before World War II, you know, many of the cleaners that were used were the very traditional borax type of cleaners, very simple cleaners, maybe natural oils and things like that. Of course, World War II is really where we got into the synthetic chemistry business, when we started creating a lot of different products, realized the power that we had from using chemicals and making other substances. And since that time, I think on the cleaning side, we've had a lot of chemicals proliferate and be generated. If we look across the general types of cleaners and the types of chemicals associated with them, these are some of the general classes. If we talk about solvents, if we're using solvents in that solventry cleaning process, most of the type of chemicals that we're dealing with are what we call hydrocarbons, your basic chemicals with hydrogen and carbon of various linkages. Glycols, and this is the ethylene and glycol ethers. These are the ethylene glycol, butoxyethanol, ethoxyethanol, propoxyethanol, those series of cleaners that are very common today. And one of the things we've seen too in the clean green chemistry that's starting to develop is that a lot of formulations are moving toward using more and more of these glycols. And that's because they're water-based, which means they basically dissolve in water well. And everybody likes to say we're using water-based products versus solvent-based products. But there's a problem with that. The good thing about solvents is that they may be high in the beginning and they may have a little bit more toxicity, but they go away very quickly. But these type of products evaporate very slowly into the air. So if you use those on surfaces or within materials, they will continue to outgas for an extended period of time. And it takes them a lot longer to get them out of the environment. So it might be nice to say that they're water-based, but maybe not so good from an environmental exposure standpoint. The fragrances and odorants that are very common chemicals in cleaners today, most of those are what we call terpenes. Those are things like pinene, limonene, which are your pine and lemon fragrances. I know you're all familiar with those. And mainly those are hydrocarbons of various types. Some are alcohol-based, but generally terpenes. And I'm going to talk about these in another context shortly, because they present another challenge for us. Disinfectants, sanitizers usually fall into the alcohol, aldehyde grouping of chemicals, isopropyl alcohol, ethanol. You see a lot of those. Phenolic type compounds, aldehydes, glutaraldehyde, formaldehyde, very common in disinfectants. Spot cleaners, degreasers, most of those traditionally have been chlorinated hydrocarbons because of their effectiveness. There's some movement toward even some of the terpenes to be used as solvents in place of chlorinated hydrocarbons now. And then in aerosols, and a lot of cleaners are being dispersed by aerosols, a lot of those are being propelled by hydrocarbon gases. And if you go into a building today, you will very commonly see isobutane and isobutene, because those are common chemicals used in the aerosols. And they're used so frequently in buildings that they're almost continually persistent in the buildings. Now, this is a picture. This is kind of the type of stuff we generate in our labs. This is a mass spectrum of a cleaning chemical that had just been applied to a topical surface. And this particular cleaning chemical has about 120 different chemicals in it. Okay, and I think a lot of times manufacturers or users of these chemicals really don't realize this information because they know oftentimes you're given a material safety data sheet, and that has very limited information on the chemical constituency because they're only required to list chemicals of a certain percentage on there, and also only if they fall on certain regulatory lists. And so there are going to be many other chemicals in there, and a lot of times there are contaminants in there that you get from the supplier that you may never know are there until you do some sort of measurement like this. Now, here are some of the top 20 VOCs. We call it the top 20 list of volatile chemicals that are found in cleaners and the types of cleaners that they are typically found in. And if you look across this list, there's some really bad actors up here. 1,4-dioxane is a class 1 carcinogen. It's still commonly being used as a solvent. Butoxyethanol is a Proposition 65 chemical in California. There is concern that butoxyethanol is functioning much in a way as, you all know what NPE is, nonylphenyl ethoxylate. Y'all heard about that particular chemical? That's the chemical that Walmart has put on their hot list. We're going to phase this out of cleaning chemicals that we purchase because these type of chemicals are believed to be what we call endocrine disruptors. They mimic female estrogen hormones. And at least the science that's beginning to develop is showing that they operate in that way. And so in return, what they do is cause reproductive and developmental effects among childbearing women and babies when they're in the fetal development stage. So a lot of concern about those particular chemicals right now. And interesting enough, this is probably the most common chemical that you see today from cleaners because I think it's a great surfactant as well as solvent. Your glycol series are very common, and I talked about a number of these. Limonene is a terpene, pinene is a terpene. Those are the fragrance chemicals that can also be good solvents. So they kind of can serve dual purposes. Some of your chlorinated solvents, formaldehyde, biocide, although we see that phasing out also of many of the cleaning chemicals. But these are some of the common ones that you might find. Now, if we were to take all of those chemicals together and look at them relative to their potential risk to the environment and to public health overall, and put them into categories, this is pretty interesting. We find that majority of them are what we call odorants and irritants. You might smell them, and if they're at high enough levels, they may irritate you, but they probably aren't going to cause any sort of long-term health concerns. So if you use those and you stay away from them and they go away quickly, they probably aren't that much of an issue. But then there are others that fall into reproductive toxin scenario, carcinogens. I'm sorry, this is the reproductive toxin. Carcinogens, and this is other, where there are health data developing that some of these chemicals may fall into some of these more toxic situations. So it really raises the question of making sure we know what we're dealing with and that we're using appropriate chemicals, that we look for alternatives, that they're safer chemicals, that we don't use more than we need to be using, which is also, I think, a very typical scenario, a lot of people think that more is better, and that's definitely not the case. I know that many manufacturers and distributors are now going to packaging where you can only use the specified amount for dilution and that type of thing, so it doesn't give one the discretion of pouring a little bit more in if they want to. Now, one thing I also wanted to bring up, because this is something, you know, that is in everyone's vocabulary today, and it's, you know, it's CO2 credits and how are we impacting the overall environment, global warming, and are we supporting Al Gore? How many Democrats do we have, and that type of thing. But VOCs from household commercial cleaners are really being used at a pretty significant rate, and these are the tons per day that are being generated by these types of cleaners. And this is in the indoor. These are just this doesn't even address manufacturing, but just being used on a day-to-day basis. We are generating a lot of VOCs in the indoor environment, which relate to ultimate transformation in the atmosphere and contributing to our overall issue. And I wanted to bring it up because I think it's something that you will be facing, because now everyone's talking about how to reduce these and can we trade, can we get credits and that type of thing. So there'll be more focus on understanding what your contributions are and what you might be able to do to reduce them. There have been a fair number of health-related studies relative to the impact of cleaning on health, and there probably have been more of these than there have been cleaning efficiency, effectiveness studies. And to me, that's pretty dangerous, because when you have these type of studies getting out into the public showing that cleaning chemicals are a problem and they are related with certain types of health effects, but we don't have the other studies to show, you know, how those cleaners are working, whether they're really being effective, to show any sort of benefit to them, and also whether or not the effectiveness can be achieved by using less or looking at alternative approaches, then the public doesn't have that information. All they know are the bad things. And these are just an example of some of the information out there. NHANES, which is that CDC study, has also shown work-related asthma, occupational asthma, among professionals working in the cleaning industry. Survey of nurses has shown occupational asthma related to alkyd ammonium chloride. This is a chemical I didn't mention earlier, but this particular chemical is a common antimicrobial chemical. And we actually had a very interesting situation about 2 weeks ago. We were in the International Money Fund building in Washington, D.C., and they had an outbreak of administrative staff breaking out with rashes on their arms and then on their faces. And they had some new furniture installed about 6 weeks prior, and they were convinced that there was formaldehyde coming off of the furniture, which was causing this type of dermatitis among the workers. And it was very strange, because dermatitis from formaldehyde exposure is not something that you would expect. And when the building was actually studied, we found that they were dispersing an aerosol product containing alkyd ammonium chloride to all of these workers, who were then taking it and spraying their desk, okay, twice a day, and not removing it in any way, spraying it, letting it dry. The outside of the can says clearly, avoid human skin contact. So it just, you know, and it was a commercial cleaner that they had purchased from Office Depot, that type of thing. But it, you know, that's an education issue. And again, it's more of a situation of product not being used properly. The state of California, which is always very active in many of these issues, as you know, has been doing a lot of studies on cleaning products. They have been going in the marketplace, they're taking cleaners off of the shelf, they're taking them back to their labs, studying them, determining what sort of chemicals are there, what are they, at what levels, trying to assess whether or not there are any health concerns. And they do have a major report out, and they are continuing those studies. And if you've been keeping up with California, they are starting on the regulation route for indoor air quality. They have now regulated the release of ozone from air cleaners or any sort of electronic device that can release ozone. They have proposed regulation on the reduction of formaldehyde from pressed wood products. So they are getting very progressive in this area, and really the first state to have this type of indoor air quality regulation. But they have identified cleaning as a process for them to be concerned. And here are some of the chemicals that they have focused on in their studies, because they've already categorized them as Proposition 65 toxic chemicals. Are you all familiar with Proposition 65? If you do business in the state of California and you have any chemicals that exceed certain dose levels which they prescribe to be dangerous, then you have to label your product as containing them and make everyone aware of it. And that goes not only, it's residential, commercial use of product in any sort of situation. Yeah. Certain types of chemicals too. This is some of the new chemical chemistry that's being studied right now. And there's certain chemicals, and we kind of refer to them as the stealth bombers, because they cause problems that are secondary. You don't know that they're going to happen. But they do. And the majority of those are the terpenes. Those are your terpenes, your limonene, your pinene, your linoleuls, chemicals like that that are traditionally used as fragrances, and in some cases solvents. But when these chemicals outgas from a cleaning process or they're left on a surface, they react with indoor ozone. And ozone is an outdoor air pollutant. Everybody's familiar with ozone, but it does come inside. And also we have electronic office equipment that generates your laser printers, your photocopiers that generate ozone on the inside. So we always have ozone on the inside, but these particular chemicals react with ozone as well as other radicals in the air to create more hazardous chemicals. So you get this side reaction going on. And it doesn't take much of these chemicals to cause this type of problem. And the reactions are occurring both in the air as well on the surface if these chemicals are left residual on the surface. And California has identified this as a very significant issue and one of the things that they are looking at. But in terms of kind of the movement that's going on relative to cleaning processes, obviously reduce exposure in any way that you can. So there's more emphasis on controlling the amounts that are being used, the frequency of cleaning, really doing what's needed but don't go overboard, making sure that spaces are ventilated during and after cleaning to flush any residual chemicals out. There's a lot of activity relative to rinsing after cleaning is happening. We've been in schools now where they're almost taking a hose and hosing surfaces and things down now because they believe they want to wash away any residual chemicals that may be occurring. Vacuuming, removing effectively by vacuuming. We've probably made a lot of good progress in our vacuum cleaners and have a lot more effective ones on the market now. There are a lot with good HEPA filters and processes that remove a fair amount of the settled dust and also remove residual chemicals that may be left and that type of thing on all type of surfaces. You can use portable HEPA cleaners now to clean topical surfaces, not just flooring, shelving and things like that. People are using it to clean their computer keyboards and just about anything they can think of. And another big movement is to avoid terpene-scented cleaners. And you will start seeing specifications now where organizations want no fragrant chemicals, and they especially don't want the terpenes that have been identified as contributing to their site activities. And then overall, a greater movement toward more sustainable and less toxic formulations. And the issue with that is, what is that definition? And unfortunately, the market is driving a lot of kind of the new green chemistries, green cleaning that's going on out there without much definition behind it. And we hear a lot about VOC products. There are a lot of products out there with claims that are totally unsubstantiated. One of the big ones that's used, VOC-free, and cleaning chemicals, that's just not true. All chemicals have VOCs. What this means is it's been studied in some way which indicates that it's non-VOC, but there are probably certain chemicals that were eliminated from the equation that didn't have to be counted in, or the testing was done in a way where it was not sensitive enough to measure those VOCs. So most people now are becoming very leery of these type of terms. If somebody says it's natural, alternative, generic, well, we don't know what that means because there's really not a definition. And this particular data shows you why it's a problem. Here are 3 cleaning chemicals that were studied by the state of California. These were the VOC content levels on the label. This was the VOC content that was measured by them independently. And these two are they're in the same range. This was higher than what they had claimed. But then they did emission studies on these. They actually applied the chemicals in the way that they were recommended and then looked at what that meant to the air. And these are the air levels in milligrams per cubic meter that arose from the use of those chemicals that were claiming to be non-VOC. The significance of this is 0.5 is the traditional recommendation. And all of these, except for this particular one, these two, this one in particular, was way above. And so VOC content in this situation doesn't have much relevance. There are a lot of processes technically available now for evaluating cleaning products and processes, laboratory, environmental chambers, on-site studies. Environmental chamber studies are ones that are being very commonly used now, where you can isolate your products and your processes and put them in a controlled environment and use them and then measure what's happening. You can also have surfaces, either porous surfaces or solid surfaces, that can have loads of contaminants like allergens and dust, so that the efficacy of the process in terms of removal can also be evaluated. Okay. These are some slides of some cleaning processes occurring in an environmental chamber. This particular one where topical cleaners were being used to look at efficacy of removal of some dust allergens, and also the impact of those cleaners and the process on what might end up in the air. These are some smaller environmental chambers with textile materials that had been cleaned and actually washed with detergents that contained microbubbles with formaldehyde resins. Concern was whether or not formaldehyde from that cleaning from those dispersal type processes could actually get airborne following the cleaning process. And in these type of studies, you can actually learn quite a bit. You can see chemicals as well as particles, and everybody's concerned right now with what we call respirable particles. And those are the very fine particles that get in the air that you really can breathe deep into your pulmonary system. And you can look and you can see if the process is contributing them into the air, if they're removing them. You can look and see how things change over time. Do they go down? This is obviously the pattern that you want. There are a number of consumer products now in the marketplace that are being applied to the air with the intent of actually decreasing or causing allergens and particles to fall out of the air. And so you would get some sort of look like that. But looking at extraction efficiencies, looking at what type of room exposures, personal exposures for workers might be occurring, what the impact following cleaning is, assessment over time, and then taking all that information and being able to really assess what that means in terms of health consequences. This is another environmental chamber study of an actual carpet cleaning study looking at different processes and how effective they are in removing dust and microbiological and animal allergens. Okay, and there have been a fair number of studies. The Carpet and Rug Institute has sponsored a number of those studies in the past to help understand this issue. And a little bit of data on this. This is an example of a particular process showing how effective it was in the removal of microbiological fungi from the actual carpet. This was actually hot water cleaning process, extraction process. And then this slide shows you the difference in the chemistries and the processes available. This was 5 different techniques of carpet cleaning, looking at airborne reduction in fungi before and after cleaning. And you can see there are a couple that after cleaning had a very significant impact. But there are also a couple that had very little impact. So their cleaning efficiency in terms of removal of those biological contaminants was very insignificant. I honestly don't remember. Okay. And these are 2 of the that previous slide was showing actual fungal dust removal. This particular one shows the 2 extremes in terms of their contributions of VOCs. One of them actually contributed significantly to the indoor air pollution by nature of the actual substance that they were using to in the cleaning process. So a lot of variation and a lot of information that one should know relative to this. One thing that's also happening on the cleaners and cleaning side are the establishment of standards for what's toxic and what's not toxic. Many of you may know that Green Seal is in the process of updating their cleaning standard. They will be in, it'll be a very political process. There are a lot of stakeholders and people involved, but they do plan on updating it. They're working primarily with the state of New York, who wants to make sure that their standard addresses sensitive populations. But there will be a lot of elements related to these type of things, carcinogens and toxic effects, developmental effects, and VOCs, formaldehyde, in terms of reduction, in terms of what's residual in the cleaned product, as well as what ends up into the air. And they do plan to incorporate an emissions component to that particular standard. So that's kind of what I had, I think, in summary. I think taking all of this information and balancing the significance and the benefits of using chemicals versus the risk is a very important consideration as we go forward. And I think with all that's happening in the green market and with all the greenwash that's out there right now, one needs to be very careful as you go down that step and get pushed by the market to provide green cleaners, that you really understand what you're providing, what it means, and make those definitions out to the consumers and the users. But I think overall our primary objective in this whole process is to protect public health as we're maintaining and the environments and the materials. Thank you.